Hi there, this is Mike Lopez, and in this video we're going to be looking at an RC circuit, a series RC circuit, and in particular looking at the exponential growth and decay properties of this arrangement. Okay, so let's first of all draw ourselves an RC circuit. So we have a battery, here's a switch. The experiment will start once the switch is closed. Here's resistor R, here's our capacitor C. We've got a supply voltage, we call it Vs, why not? And what we're interested in, I can change to red, is once that switch is closed, we're interested in the current through the series circuit and also this capacitor voltage Vc. Okay. Once the switch is closed, we would like to know what that capacitor voltage actually looks like. So in terms of time on the horizontal, here's the origin, here's your capacitor voltage, and what we're expecting to see, as you'll see later on in a live simulation, is an exponential growth of this form. Okay. And if I was to mark out where that plateau is on the curve itself, you will find that it is Vs, the supply voltage, which is the maximum value for the capacitor voltage of here. Okay, so this whole arrangement is exponential growth. Okay, something else we might be interested in, if I draw those axes again, is that current marked in red over here. Okay, and what we see from the current point of view is there is an exponential decay in current. Okay, so it's going to come down this way like so, and the maximum value of current is the very instant when the switch is turned on. Okay, so Vs over R, and yes, it's exponential decay. Okay, let's have a look and see if we can put together some formulae for exponential growth and decay for these parameters. So we're looking at the capacitor voltage Vc equals Vs times 1 minus e to the minus t over Rc. And in terms of the current graph over here, we're looking at I equals Vs over R times e to the minus t over Rc. So in RC circuits and RL circuits, whenever you see a 1 minus in brackets, you always think of growth. Okay, let's scroll down a little bit and let's see if we can analyze this expression, and let's see if we can find for R. Okay, so we'd like to find an expression that says R equals blah blah blah. Okay, so how are we going to do that? Well, maybe the first step might be divide both sides by Vs. Okay, so we're going to have this in red. Okay, so we'll have Vc over Vs equals 1 minus e to the minus t over Rc. Okay, then we can move along and we can say, if I get this term including its sign and move it over there, and then I take this term, including its sign, which is positive of course, and do a horizontal transposition. That will then give me e to the minus t over rc equals 1 minus vc over vs. Okay, let's change colour again. What I'd now like to do is release this r term somehow, and the best way to do that is to hit both sides with a log base e. Okay, so we'll take the log base e of both sides. So log e of e to the minus t over rc equals log e of 1 minus vc over vs. Okay, just move down a bit. Now, when you take the log e of e to the something, the answer is the something itself. Okay, so we're going to have, therefore, minus t over rc equals log the base e of 1 minus vc over vs. Okay, and of course, again, let me just highlight and choose blue to remind ourselves we're trying to isolate r. So it might be a good idea to move the r term on a diagonal. In other words, multiply both sides by r if you like, so they cancel on the left and r appears on the top right. And we can do the same thing with this whole term here, and we can move that on a diagonal, and that appears on the lower left. So therefore we end up with r equals minus t over c log the base e of 1 minus vc over vs. Okay, so that's how you analyze a series RC circuit, and one example here of transposing to find for R. Okay, here you can see our series RC circuit. We've got a 1 meg resistor, a 1 microfarad capacitor, and a 10 volt battery. Here's our transient analysis limits dialog box. Okay, we're looking at the VC node, X range 5 to 0, Y range 10 to 0, and we've taken off the operating point there, time range 5 seconds. We've got a few other settings here which you can play about with, of course. We click on run, and hopefully you're going to see that growth, exponential growth in the capacitor voltage appear on screen here.